Okay, today actually we should discuss today questions for conical pendulum section, and that is the end of circular rotational motion. But I'll give one more week for you to revise and complete your theory about this conical pendulum section. And next week I'll discuss the questions from related questions for conical pendulum. Today, I'm going to discuss a past paper question, and we should go to the next theory section. Right. Let me show you a question. Give me a minute. Give me a minute. I'm going to select a past paper question because we have reached to the end. We have reached to the end of circular and rotational motion. Can you see the question, Lamai? Right. This question was given in 2016. Please tell me whether you are able to see the question clearly or not. Lamai. 2016 first essay question, which is given from mechanics lesson. A particle of mass m1 kilogram is fixed to a rim of a horizontal ring of radius simple r and negligible mass as shown in figure 1. So this is the particle. It is connected to a rim. Mass of the ring is negligible and the rim is horizontal. The radius is r. POQ is a vertical axis passing through the center of the ring. So it means POQ is vertical, radius is horizontal. POQ vertical, it is going through the center of the ring. The ring is horizontal. Write down an expression for the moment of inertia, I1, of the particle about the vertical axis of POQ in terms of M1 and R1. What is the moment of inertia here? If a particle is moving along a circular path of radius simple r, when the rim is rotated, the particle will be moved along a circular path of radius simple r. Therefore, what should be the moment of inertia? Lamai? Anyone?
M1.
Yes, why not? So moment of inertia I1 equals M R M1 into simple R square. That's it. So simple. Right, India? Start the heading as 2016 AL first essay question. Answer for Roman number 1 is I1 equals M1 R square. I equals MR square moment of inertia. Right, India? Here they have given the mass of the particle as M1. So you have to say I1 equals M1 into R square. So sometimes you may forget to keep the mass as M1. See, they have said M1. So do not forget to mark M1 without writing only M. Right, let's check this next question. Another particle of mass M2 is now fixed to the rim, which is diametrically opposite to M1. So what do, dear? They take another particle. That particle is connected to the other end of the rim like this. Actually, no need to mark the radius like this. The only thing is you should mark the particle. So this is the other particle. Another particle is connected. Even no need to draw the rim, right? So what is the mass of this particle? M2. What is the radius? It is the same ring. Therefore, radius is R. And the system is rotated about OQ. This is O, this is Q. It means you can imagine that a nail is going through the center of the wheel and the rim is rotating like this. When the rim is rotating, particles are also rotated. So that's what you want to think. So this is the second particle, M1. The radius of the ring remains unchanged as simple R. So this I'm talking about Roman number 2. With a constant angular velocity of omega. Everything is rotated with an angular velocity of omega. If I2 is the moment of inertia of mass M2 about the axis POQ, write down an expression for the total rotational kinetic energy of the system. What is the total kinetic energy, dear? I'm talking about Roman number 2. So total kinetic energy means the summation of kinetic energy of M1 plus kinetic energy of M2. Am I right? Lamai? Hello?
Yes, sir.
Right. So kinetic energy of M1 means half I1 omega square. Do you remember this equation? I1 is said to be the moment of inertia. This is the equation. Half I omega square. Kinetic energy of the second particle. Half I2 omega square. Am I right? So finally, look at board. Finally, you should identify that the term half can be taken out from a bracket. And again, the term omega square can be taken out from a bracket. So what are the terms inside the bracket there? If I take half and omega square out from a bracket, what will be the terms which are outside the bracket, inside the bracket?
I1 plus I2.
Very good. Here the remaining term I1, very good. And here the remaining term is I2. So I1 plus I2 times omega square. So this is the final equation. This is what they have asked you to write. If you want, you can draw this figure. I don't know whether if you want, you may draw this figure. Where can I keep the answer? Like, okay. If you want, you can draw the figure and write the answer. Start there. Start. This is the answer. This is the figure. Roman number 2, I think it's okay if you draw the figure and write the answer. It's better to draw the rim in dotted lines here because okay, you draw the figure exactly like this and write the equation. That's it. Right. Lamoy, can you hear me properly? Right. So let's go to the next part of the question. So this is the diagram. Let me keep the diagram. Okay, let me move it up. Right. Let me move this little bit up further right. Okay. So this is the second particle. This is the radius of the circular path. Mass of the second particle is m2. So I think you are okay with those things, right? Right. This is the answer for the first one. Let me erase it. If I naught represents the total moment of inertia of the above system, what is the system there? System means there is a ring. Ring does not have a mass, therefore I do not draw it. Right? As the ring does not have a mass, I'm not going to draw it. But there are two particles. The two particles have masses, right? Mass of the first particle is m1 kilogram. Mass of the second particle is m2 kilogram, right? The both particles are moving along the same circular path of radius simple r. Particles are actually moving along horizontal circular paths, right? So total moment of inertia of this entire system is given as I naught, right? Represent total moment of inertia of the above system means simple A Roman number 2 about the axis POQ. POQ means you can imagine that a line or nail which is going through the center of this circular path. So it means all the things are rotated about this POQ, right? An imaginary nail. That's how you want to think. Using the expression obtained in A Roman number 2. This is Roman number 2, right? A Roman number 2 means this question. Show that actually this should be I naught equals I1 plus I2. Show that it should be like this. I naught equals I1, I naught equals I1 plus I2. Show that I naught equals I1 plus I2. There's a typing mistake. I naught is not there. How do you prove this, dear? If I naught represents the total moment of inertia of the above system in A Roman number 2 about the axis POQ, this is POQ, using the expressions obtained in A Roman number 2, show that I1 plus I2 equals I naught equals I1 plus I2. So, but what is the normal total kinetic energy equation here? Total angular kinetic energy. Normally we write the equation like this. Check whether I am right there. Normally we write this expression as half into moment of inertia of the system I into square of the angular velocity. Am I right there? This is how we write. Am I right or wrong?
Right, sir.
Right, yes. But here, thank you, dear. Here they have given the total moment of inertia of the entire system is I naught. But previously we have proved that this is the normal expression. Previously we have proved that total moment of inertia equals half into I1 plus I2 into omega square. Am I right there? So this is the expression that we have obtained in simple A Roman number 2. Now what will happen here? Now there are many terms that can be cancelled out. You see, this half and this half cancelled out. Omega square and omega square cancelled out. So what are the remaining terms then?
I naught equal I1 plus I2.
Yes, remaining terms only I naught, and the other side we have I, and the other side I have I1 plus I2. That's it. So this is how we prove it. This is the answer. This is the answer for Roman number 3. Write it there. That's what you want to do. I use the arrows to show you the terms which are cancelled out. I use the arrows to show you the terms which are cancelled out from each other. That's the answer. So simple, right? Complete it there. Right. So we have successfully answered the first 3 questions. Right. Look at board. Let's go for the next question. Is there anybody who wants any more time to write the answers, dear? So all the answers are here for Roman number 1, Roman number 2, Roman number 3. All the answers are here. Do you want any more time to write these things, dear? This is the diagram. This arrow is the POQ axis. Right. I think time is enough. Let's go for the next question. Simple B. So it means we have answered simple A, Roman number 1, Roman number 2, and Roman number 3. Simple B. Instead of M1 and M2, 10 identical particles, 10, number 10. 10 identical particles, each of mass simple M, are now fixed to the ring of the ring with the equal spacing. Distance between any 2 particles will be the same. There are 10 particles. They are identical. Mass of each particle simple length. If the moment of inertia of a particle about the POQ axis is, we have to go to next page. Just remember the question. Instead of M1 and M2, 10 identical particles, each of mass simple M, are now fixed to the rim of the ring with equal spacing. If capital I is the moment of inertia of a particle about the vertical axis POQ, moment of inertia of a particle is capital I. Remember it. Now let me erase everything and let me go to the next part of the question. Right? Let me go to the next part of the question. Next part means actually next page. Let me go to the next page. Right. See, they have given us the figure. Right. How many particles are there now? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 particles are there. Right. Then moment of inertia of a particle is I. Write down an expression for the total moment of inertia of the system about the vertical axis POQ. What is the moment of inertia of a particle, dear? We are going to answer for simple B question. Simple B question. They have given this data. The moment of inertia of a particle. Moment of inertia of a particle, they have given I. But what is the normal expression that we write moment of inertia of a particle, dear?
mr square.
mr square. So we know it. So that is mr square. So therefore, what should be the, Lamai, you should answer me, what should be the moment of inertia of 10 such particles? How do we find it there?
10 mr square.
Yeah, moment of inertia of a particle is mr square. Therefore, moment of inertia of 10 particles, mr square into 10. But they have given us the letter I. So we have write I times 10. And let's put another equation mark and write I means mr square into 10. So it's better to write the answers in the examination like this. We have given everything. Moment of inertia of a particle is I. Therefore, moment of inertia of 10 particles, 10I. But when a single particle is moving along a circular path, moment of inertia mr square. Therefore, moment of inertia of such 10 particles, mr square into 10. Write the answer like this, dear. So it's a very simple question. Those are the things really asked in the examination. Do not try for the questions which are not related to the advanced level examination of Sri Lanka. You should follow the syllabus. You should be prepared according to our examination papers. Write the answer. Start. Right. I think time is enough. Now let's move up. Let's go to simple C question. Right. What is simple C, dear? Read. Now the ring described in simple B above is fixed to an axle of negligible moment of inertia. That's a typing mistake. And coinciding with the vertical axis POQ using symmetrically fixed spoke of negligible mass as shown in figure 2. The system is then started rotating from rest at the time t equals 0 in a horizontal plane about the axis POQ with a constant angular acceleration alpha and reach to a constant angular speed omega. Now you should not worry about any of these descriptions. May I tell you the reason? We should not worry about any of these descriptions because you see the things that they have said there. Fixed to an axle of negligible moment of inertia. Negligible moment of inertia means no mass. If no mass, this is inertia, typing mistake, and coinciding with vertical axis using symmetrically fixed spokes, again negligible mass. So masses are negligible. Therefore, do not worry about the frame. Do not worry about the axle. Can you understand it? They have given a huge description, but you should not worry about that description because all the things that they have connected, no moment of inertia, no mass. When things are no masses, why do you worry about them? Just forget them. Think only about the particles. Therefore, the moment of inertia of the entire system still remains unchanged as 10 times I or 10 times mr square. So the system started rotating from rest. It means initial angular velocity is 0 in a horizontal plane about the axis POQ with a constant angular acceleration alpha and reached a constant angular speed omega. So starting from rest and reached to the velocity of omega. Obtain an expression for the time taken by the system to reach to the angular velocity omega, velocity or speed, angular speed omega. So it's so simple. The story is clear. Do not worry about any of the things. We should not worry about the system because system does not have any mass, right? Now, initial angular velocity, they have given omega 1 as 0. Final angular velocity, omega 2, they have given it as omega. And angular acceleration, they have given alpha. They ask us to obtain an expression for simple t. Am I right? So this is what they have asked in Roman number 1 first question. Obtain an expression for the time taken by the system to reach to the constant angular speed. So what is the equation that we should use there? We have a standard equation. What is it there? Omega 1, omega 2, t and alpha. What is the equation?
Omega 2 equal omega 1 plus alpha t.
Very good. Omega 2 equals omega 1 plus alpha t. Very similar to the equation of V equals U plus AT. Write all these things, dear start. Write them all. Right. So what is the expression there? Omega 2 is omega. Omega 1 is 0 because the motion starts at rest. That's what they have given. Plus angular acceleration alpha time taken is t. So finally, actually we obtain that omega equals alpha times t. Just take alpha to the other side, then you will get omega divided by alpha equals t. This is the expression here. This is what you want to do. Let me write alpha, right? Omega 2 equals omega 1 plus alpha t. Omega 2 is omega, omega 1 is 0, alpha t, alpha times t. So omega 0 plus alpha t means alpha t, right? Just take alpha to the other side, then you'll get omega, divided by alpha. Omega divided by alpha is t. That's it. Who got this answer? Please raise your hand up. Please raise your hand up if you got this answer, Lamai. Very good. Happy. Right. Second question. How many revolutions have been made by the system when it reaches the constant angular speed? So it accelerates until it reaches to omega. After that, velocity is not changed. That's the meaning of the question. The system accelerates until it reaches to a velocity of omega. After that, it does not. After that, it does not accelerate any further. That's the meaning. Right? So question asks the number of revolutions made by the wheel when it reaches to this velocity. So you should understand that we cannot find the number of revolutions at once. We cannot find the number of revolutions at once. Here actually we just obtain expressions for them. T equals omega divided by alpha. This is alpha, omega divided by alpha, right? Okay. We cannot find the number of revolutions at once. What should we do first? Before we find the number of revolutions, we have to do something first. What should we do, Lamai?
Finding theta.
Find in the data. Very good. So let's apply the equation. Theta equals omega 1 times t plus half alpha t square. Can you give an effort to obtain the answer here? Theta equals omega 1 t plus half alpha t square. Alpha is a given symbol. Can you give an effort to obtain expression for theta? Try dear. First obtain an expression for theta. After that we can find the number of revolutions completed by the wheel. Start dear. So what is it here? Theta equals omega 1 is 0. Time is t. Plus half. What is alpha, dear? Sorry, alpha is alpha. What is T, dear? We should
Omega
use
over alpha.
that's the point. T is omega divided by alpha. That's the point. And you have to get the square. Oh, still let's keep this T, but at the end of everything, we should use that expression also, because T is not a given expression. Now 0 into anything, Lamai? Theta equals 0 into anything is 0 plus we have alpha t square divided by 2 half alpha t square. How do you simplify this further? Half into alpha into t is omega divided by alpha, and we have to get the square. Let me write some. It will be somewhat difficult for me to write. Right. So this is 0. This is half. This is alpha. Time is omega over alpha. We have to get the square. We have to get the square. Like this. Then what will happen? So what should be the final result of theta? Have you written up to this, Lamoy?
Yes, sir.
So how do we simplify this further? Let me use my normal whiteboard. Can you see my normal whiteboard?
Yes, sir.
Yeah, sir.
Yes, sir.
Right. Finally, we have obtained an expression something like this. Theta equals 0 plus half into alpha into omega divided by alpha and square of that. Am I right? Can you see the board clearly? Right. So we should not worry about this 0. This is half alpha omega square. Omega square means actually omega into omega. Square of omega means omega into omega. Similarly, alpha square means alpha into alpha. Alpha into alpha. Now what will happen? This alpha and this alpha cancel. The remaining terms will be 1 into omega means omega square divided by 2 into alpha. 2 alpha. This is 3. Who got this answer? Who got this answer? Please raise your hand up in the Zoom chat. Right? So omega square means omega into omega. Alpha square means alpha into alpha. One of the alpha terms cancelled out. Only you have omega into omega. Omega square divided by 2 alpha. Right? So many of you have obtained the answer. But this is not the thing that they have asked. They have asked us to find the number of revolutions completed by the wheel or by this cycle. How do you find the number of revolutions here? How do you find it? The number of revolutions. The number of revolutions is equal to the rotated angle. Rotated angle divided by angle of a revolution. Am I right? What is the rotated angle here? If you have, let's say this is one of the spoke in the ring, as they have mentioned. So if this rotate one cycle, what is this angle here? How many degrees? What's the angle of this angle in degrees?
360 degrees. 360 degrees.
360 degrees. What is this angle in radian?
2 pi radian.
2 pi radian. So what is the SI unit of angle here? What is the SI unit that we use to measure angle?
Radian.
Radian. So rotated angle is theta divided by angle of a revolution is revolution. Angle of a revolution is 2 pi. 2 pi radian. One revolution, 2 pi. So theta was found as omega square divided by omega square divided by 2 alpha. This should be divided by 2 pi. Now what will happen? Omega square divided by 2 alpha, division becomes multiplication. Division becomes multiplication when you take the reciprocal. So this will be 1 over 2 pi. So finally, omega square into 1 is omega square, 2 into 2, 4, alpha into pi. So this is the number of revolutions completed by this system when it reaches to a velocity of omega. Write them all. If you have any doubt, please unmute the mic and ask or send a message to the Zoom chat. Please tell me once you have written them all. When you have written them all, please tell me. In physics, we should write only the unit in the final answer. But in physics, when we use symbols such as only, here we have only the symbols. Omega square, alpha and phi all are symbols, then we should not write units. In physics, we write only the unit. When we get a numerical solution, when we get a number as the final answer, we should write the unit only with the final answer. In other places, we do not write units. That's how we work in physics. Right. Let me show you the next question here. Right. What is the next question? Write down an expression for the. This is simple C. We have answered C Roman number 1. First 2 questions we have answered. Right. Then C Roman number 2. Write down an expression for the centripetal force acting on one particle when it is rotating about the axis POQ with a constant angular speed omega. Such a simple question. C Roman number 2. This is 2016 paper, dear. Few years ago, just few years ago. See the things that they have asked. This is the problem here. Many of the students, they are doing questions which are not related to the our examination, which are not related to our examination, not in our syllabus. So these are the real things they ask in the exam. Read C Roman number 2. Write down an expression for the centripetal force acting on one particle when it is rotating about the axis POQ with a constant angular speed omega. How do we do it here? Right, I think you are able to see the board. So they have asked, they have said that there is a particle, it is moving along a circular path with a constant angular velocity omega. We know that for any particle, C Roman number 2, for any particle to be moved along a circular path, there must be a force acting on that particle. And that force should be directed to the center of the circular path. So, if this is the particle, if omega is its angular velocity, right, there must be a force, let's say Fc for the centripetal force, which is directed to the center of the circular path. Right? So, let me take simple r as the radius of the circular path. Right? No need to draw a figure in the examination. But if you draw this figure, it will be very easy for you to understand. C Roman number 2, please draw this figure. After that, I'll give you the answers. So FC is the centripetal force. Centripetal force. FC is the centripetal force. Complete? Right. We know that when there is a force, there must be an acceleration. Whose law is that there? If there is a force, there is an acceleration. Whose law is that? Lamai?
Newton's law.
Newton's law. Newton's second law of motion actually. So, because of the centripetal force, there must be an acceleration. That acceleration is said to be centripetal acceleration. If there's a force, there must be an acceleration. Because of the centripetal force, there must be an acceleration. The acceleration because of the centripetal force is said to be the centripetal acceleration. So what is the equation for centripetal acceleration here? There are three equations. Give me one of them.
V
What
omega.
are the equations that can be used to find centripetal acceleration? Lamai? Lamai, what are the equations that can be used to find centripetal acceleration?
V omega. V omega.
V omega. Yes. The next one.
R omega square.
R omega square. Next one.
V
V
square
square
over
over
R.
R.
Actually, V square over R equation is the most widely used equation. V square over R is the most widely used equation, but here V is not given. They have given omega and R. Therefore, in this case, the best equation is R omega square. Can you understand it here? The most widely used equation is V square over R. But here we cannot use it because they have given R and omega. Therefore, best equation for this equation is R omega square. Now we want to obtain an expression for the centripetal force. This figure and this equation, they are just supporting details. They're just a support for you to get the answer, right? But what is the final answer? The final answer is we should use something like this. Let us apply F equals MA equation. Let us apply F equals MA equation towards the center of the circular path, towards the center of the circular path, the center of the circular path, right? The only force acting towards center is the centripetal force. Let us apply F equals MA equation towards center of the circular path. So F equals MA. F is the centripetal force. Centripetal force. Right? Mass is M. Angular centripetal acceleration is R omega square. So this is the answer. So in the examination, you should write only this sentence and this equation. That's all. This figure and these equations just supporting details for you to understand. You should write only these parts, these sections. Okay? Write them. Write them all. Right. Did you write them all, dear? Who wants more time to write these things? Lamai? Who wants more time? Right. While you are writing, let me show you the question. Right. Write down an expression for the centripetal force F. Write down an expression for the centripetal force F acting on particle on one particle when it is rotating about the axis POQ. Right now we have successfully answered simple A, B, C, D. No, only A, B, C. Now let us go for simple D question. What is simple D? Let me read it. The structure of the merry-go-round shown in figure 3, not figure O, figure 3. This one, this is the merry-go-round, which is at rest, is similar to the structure, which is at rest, is similar to the structure of the system described C above. However, instead of fixed mass as simple M, the system has 10 chairs occupied by riders and hung by the chains of negligible mass. There are chairs, you see, there is a chair, a man is sitting on it. There's a chain, right? Chain or a wire which is connected to the rotating ring, right? They have said mass of the chain can be neglected. It's okay. The moment of inertia of the merry-go-round without the riders and chairs. That is important. The moment of inertia of the merry-go-round without the riders and chairs about the axis POQ is 32,000 kgm square, right? So you see the structure, 32,000 kgm square. Without the riders and chairs, only the merry-go-round has a moment of inertia. Only the merry-go-round has a moment of inertia of 32,000 kgm square. Then we have to go to the other page. We have to go to the other page. So remember that without the chairs, without the riders, the ring, the merry-go-round ring has a moment of inertia of 32,000 kgm square. So let's go to the other page. Right. What have they asked? Consider a situation where the merry-go-round is rotating about the axis POQ with a constant angular speed of 12 revolutions per minute. Consider a situation where the merry-go-round is rotating about the axis POQ. POQ means the middle point, and some axis going through the middle point. Do not worry about it. With a constant angular speed of 12 revolutions per minute. What is this unit there? Revolutions per minute means RPM. How do we convert RPM into radian per second, Lamai?
RPM into 2 pi over 60.
Very good. The RPM value is multiplied by 2 pi over 60. Very good. When revolution per minute, when all the chairs being occupied by riders, it means all the chairs are filled with the riders. When the merry-go-round rotates, all the chains are inclined to the vertical by an angle, and figure 4 shows the situation with respect to one rider. So you see, when it is rotated, when the merry-go-round is rotated, the chain and the rider makes an angle of theta degrees with the vertical. Can you see this? And 10 meter distance is there. Use phi equals 3 for relevant calculations. You can use phi equals 3 only if it is given in the question. If it is not given, that phi equals 3, you cannot use it. Let us read further. Dear. Right. If the riders are of mass 70 kg each and chairs are of 20 kg each, calculate the total moment of inertia of the system about the axis POQ. When calculating the moment of inertia, assume that total mass of the rider and his chair is concentrated at a horizontal distance of 10 meter from the axis POQ. Total mass of the man and the chair is at a 10-meter distance from the center of the ring. That's what they have said. So let's give a try there. I think you remember the question. Then they ask calculate the value of theta. What is the total rotational kinetic energy of the system? So that's the end of the question. After that, that's enough. That's all, right? So let's give a effort there. Let's give a try. Right, mass of a rider 70 kilogram. There are 10 such riders. Mass of a chair 20 kilogram. There are 10 such chairs. The total mass of the man and the chair concentrated to a point which is at 10-meter distance away from the center of the circle. That's what they have said. So it means actually this total mass is moving. The total mass of the chair and the rider is moving along a circular path of radius 10 meter. That's the meaning. Let me use my normal whiteboard. Right. Let me use my normal whiteboard and draw this figure. Can you see this board clearly, dear Lamai? Are you all?
Yes, sir.
The board?
Yes, sir.
Yes, sir.
Yes, sir.
Right. Look at board. Now I'll erase this. Right. Look at board carefully. I'm going to draw a figure. You need that figure to understand everything. Right. Look at board. So there is a ring. They have not given the radius of this ring. Let me use it as R. Right. This is also R. This is the ring. A chair is connected to the ring with the help of a chain, and on the chair a man is sitting. A man is sitting on the chair. So this is the chain's distance to the center of gravity. Entire mass of the seat and the man concentrated to a certain point. Distance to that point from the center of the circular path. This is given as 10 meter. If I want, I can take it as capital R. Capital R is given as 10 meter. And the other data that they have given us is this angle. They have given this angle to be theta. This angle is given as theta. The total mass which is concentrated at this point is simple M is equal to 70 kilogram. That's the mass of the man plus 20 kilogram. That is mass of the chair. So altogether 90 kilogram. Right. So this is the combination of this M is the combination of man plus seat. Right. Draw the figure, Dave. Draw the figure. There are 10 such seats, 10 such men. Draw this. This is the figure that we want for simple D equation. Complete it here. Right. I think you have drawn the figure. I think you have drawn the figure. So now the man and the chair moving along a circular path of radius 10 meters. That's the point. So what should you write there? The man with the chair. The man with the chair are moving along. The man with the chair are moving along a circular path. Circular path of radius 10 meters. Therefore, look at what. Therefore, what should be the moment of inertia? Moment of inertia of a man. What's the moment of inertia of a man with the seat? How do you find it? Now you can consider that. The man and chair is a point mass of mass 90 kilogram. Now they are moving along a circular path of radius 10 meter. Therefore, moment of inertia of a particle which is moving along a circular path of radius capital R or radius 10 meter is given by the equation, Lamai?
mr square.
mr square.
MR square.
mr square, yes, very good. So that is mr square. This is the moment of inertia of a man with his seat. So, M is 90, the total mass is 90 kilogram. R is 10, we have to get the square of 10. Square of 10 is 100. 100 into 90, 9,000. 9,000. Unit is kgm square. So this is the moment of inertia of one man with the seat. 9,000 kgm square. So therefore, what should be the moment of inertia of 10 such men with 10 such seats? Lamai?
90,000.
90,000.
Should be multiplied by 10, so it is 90,000. Very good. So write them there. Please write them all. You understood. You have fully understood the question. I'm so happy. But I'll explain it further. Oh, I did not ask you to do the rest of the calculations, Nick. I'm so sorry. I forgot to ask you to do the rest of the calculations. Okay, whatever. Right, now I'll do it. So you see, therefore, look at what, therefore, the total moment of inertia, total moment of inertia of 10 such men with the chairs. I forgot to ask you to do the calculations here. I'm so sorry. So therefore, the total moment of inertia of 10 such men with the chairs. So moment of inertia of a man with his chair 9,000. Therefore, total moment of inertia of 10 men with their chairs is this. That is 90,000 kgm square. Please write these things. I forgot to ask you to write these sentence. Right. Can somebody tell me the moment of inertia of the ring without the men and chairs there? Somebody?
32,000.
32,000. Right. So, the moment of inertia. Sorry. The moment of inertia of the ring without the humans, that is 32,000 kgm square. The moment of inertia of the ring without the humans, 32,000 kgm square. So what is the total moment of inertia of the entire system then? The total moment of inertia of the entire system, Lamai? What should I do? What should I do to find the total moment of inertia of the entire system? The ring and the men and the chairs?
Should that?
Sorry? Yes. We should add. So therefore, look at what, therefore the total moment of inertia, total moment of inertia of the system, total moment of inertia of the system is the summation 90,000 plus 32,000. So if you add them, you get 0, 0, 0. This is 222,000. Am I right? 122,000. Is it correct? Is this correct here? Lamai?
112,000, sir.
100 and this is 90,000 plus 10,000, 30.
Correct, sir.
122,000.
Correct.
Correct, right? Okay. Please write and let us check the question here. I forgot the question actually. I forgot the question. Let me check. What are things they ask? If the riders are mass of 70 kilogram each and the chairs are 20 kilogram each, calculate the total moment of inertia of the system about the axis POQ. When calculating the moment of inertia, assume that the total mass of the rider and his chair is concentrated at a horizontal distance of 10 meters from the axis. So we have calculated total moment of inertia. Roman number 1, calculate theta. What is the total rotational kinetic energy of the theta? So of the system. So we should find theta. We should find theta and we should find the total rotational kinetic energy. Right? So how do you find this theta here? What is the easiest method to find this angle theta? Lamai? Look at board here. I can mark the weight of this weight, that is capital MG. Capital M means actually the summation of the man and the chair. And tension in the string I can mark like this T. And I can mark this angle theta. If this is theta, this should also be theta. So if this angle is T, the component of T towards the angle, what is it now? Component of the angle T towards the angle. T towards the angle.
T cos theta.
T cos theta, very good. So this is T cos theta. The component away from the angle, T
Sin theta.
T sin. So this is known as resolving a vector into two components. We have already learned it. Component towards the angle cos, component away from the angle is sin. Can you mark these T cos theta, T sin, the capital T and theta on the previous figure? You have already drawn this figure. On that figure, can you mark them? For this capital N, this is the center, right? So this is the center of the circular path of man with the seat. This is the center of the circular path of man and seat. This is the center of the ring. They are two different things. Center of the ring is here. Center of the circular path of man with the seat is this. So that is 10 meters. Right. Once you mark this T cos theta and T sin theta, can somebody tell me what is the force component towards the center of the circular path?
T sin theta.
T sin theta. T sin theta is directed to the center of the circular path along which the man moving with his seat. That is T sin theta. T sin theta is the force acting towards the center. The force which is directed towards the center is said to be, what's the name dear?
Centripetal force.
Centripetal force. Very good. Excellent. Right. So please write T sin theta is the only force component. T sin theta is the only force component T sin theta is the only force component. T sin theta is the only force component directed towards the center. Directed towards the center of the circular path. T sin theta is the only force component directed towards the center of the circular path. Directed towards center of the circular path, comma, along which the man moving with his seat, along which a man is moving with his seat. T sin theta is the only force component. T sin theta is the only force component directed towards the center of the circular path along which a man is moving with his seat. Along which a man is moving with his seat. That's it. Right? So now what should I do dear? What should I do now? Somebody? I know the force acting towards the center. I know the radius of the circular path. I know the mass that is moving along the circular path. So what should I do next? Why? If we know the force, if we know the mass, what is the equation that can be applied?
F equals ma.
F equals ma, yes. If you know the mass, if you know the force, that's the only equation, right? So let me apply. So please write let us apply F equals MA towards the center of the circular path, right? The only force acting toward the center of the circular path is T sine theta. M. A is the acceleration towards the center. How many equations are there to find centripetal acceleration here? How many equations? 3 equations. So which is the best equation to be used here? Lamai. Which is the best equation that can be used here among the 3 equations?
R omega squared.
R omega square, very good. That is the best equation because they have already given omega as 12 RPM. As they have already given omega, the best thing is R omega square, even R is given. So M R omega square. But let me write one more equation because here R is 10 meter. So T sine theta equals M into, actually this M I have, let me use this M as capital M. Let me use this as capital R. Let me use this as omega square. And this is my first equation. I use capital M for the mass of man with the seed. I use capital R for the radius of the circular path. So they are moving along something like this, along a circular path like this. So that is radius is capital R. Complete them, dear. Right. The next thing is this man with the chair moving along a horizontal circular path like this. But this man is not moving up and he is not moving down. The man and the chair just moving along a horizontal circular path. The man and chair not moving up, not moving down. So it means the upward force and the downward force should be, Lamai?
Equal.
They should be equal. Very good. They should be equal. Right. Star point and right. Star point and right. A man with a chair is just moving along a horizontal circular path. A man with a chair is just moving along a horizontal circular path, but a man is moving along a horizontal circular path, but a man with his chair, but a man with his chair is not moving up and not moving down. A man with his chair not moving up and not moving down. A man with his chair is not moving up and not moving down. Okay? Did you write them all, Lamai? Did you write it?
Yes, sir.
Right. A man with a chair is just moving along a horizontal circular path, but a man with a chair not moving up and not moving down. Leave a line and write, therefore, the upward force should be equal to the downward force. Therefore, the upward force should be equal to the downward force. Therefore, the upward force should be equal to the downward force. So it means you can write that T cos theta should be equal to the downward force, capital Mg. This is the second equation right here. T cos theta equals Mg. Right. That's it. We have reached to the end of the question successfully. Right. Can somebody give me the next thing that I should do? Suggest. What should I do next? I want to find theta. I want to find total angular kinetic energy. So what should I do here? Finding theta means finding
1 divided by 2.
out and theta. Yes, Lamai, what should I do?
1 divided by 2.
1 divided by 2. Yes, very good. That's the next thing that we should do. Just divide the first equation by the second equation. Divide the first equation by the second equation. That's what we want to do. 1 over 2. The first equation, T sine theta. T sine theta. Here, the first equation is T sine theta. Second equation, T cos theta. T cos theta equals first equation T sine theta equals M into R into omega square. M into R into omega square. Second equation, that is just mg. Then T and T cancelled out, then you get sine divided by cos, that is tan. T cancelled out, sine theta divided by cos theta is tan theta. M cancelled out, you get R omega square over simple G. This is it. And omega, they have given 12 RPM. So this is the full answer here. That's it. Write them all. Write them all. Right. But to find the total angular kinetic energy, we cannot keep omega in RPM here. What should I do here? We cannot, I'm going to erase everything. I'm going to erase all these things. If you want, you may take a screenshot. I'm going to erase all of these things. Right, listen here. We cannot keep omega as omega with the unit of RPM. What should I do here? Lamai.
Convert it into radian per second.
Convert into radian per second. What is the method that should be used to convert this into radian per second here? What should we do?
RPM into 2 pi over 60.
Very good. Omega is given as 12 RPM. This should be multiplied by 2 pi by 60. Then RPM converted into radian per second. 12 into 2. They have asked in the question to use a pi as 3. If not, we cannot use. They have asked us to use pi as 3. This is 60. What is the easiest method to simplify? See that 12 and 60 can be divided. 12 and 60 can be divided. Right? 12 divided by 12 is 1. 60 divided by 12 is 5. This is 2 times 3. So 2 times 3 is 6. 6 over 5 radian per second. So my advice is not to divide this word. Leave it as 5 over 6. So we have found the angular velocity of the entire system as 5 over 6. We have found the total moment of inertia of the system as 122,000 kgm square. Write them all, complete. Right, finally, let's try to find the total moment of inertia of the entire system. Okay. Right, so let me write that the total whether you say angular or not, it's not a problem here. Whether you write angular kinetic energy or just kinetic energy, no problem. But let me use the term angular. The total angular kinetic energy. The total angular kinetic energy is half into I total. Moment of inertia of the entire system, I total into omega square. Just look at board. Look at board. So this is half moment of inertia of the entire system is 122,000 into omega. Omega is 6/5 and square of that. Right. Look at board. Can you see if I write one more step? Yeah. Look at board here. My advice is to do something like this. 12 divided by 2 is 6. This 2 divided by 2 is 61,000. Am I right? 122,000 divided by 2 means 61,000. Here, please write 6 square as 6 into 6 and write 5 square as 5 into 5. This will help you to simplify easily because 61,000 can easily be divided by 5. Give a try and send your answers to my Zoom chat. Try and send your answers to my Zoom chat. Start here. So the final answer is 87,840 joules. Who got this answer? Who got this answer? Please raise your hand up in the Zoom chat. Who got this? Right. So let's try for another. Let's try for another past paper question. Let's give a try for another past paper question. I think you have written them all. If you want any more time, please take a screenshot. If you want any more time, you may take a screenshot. Right, let me show you a question. Let us select a question actually. This is the question that we have already completed. This one, as I remember, I have completely discussed this question. This one, as I remember, I have completely discussed it. If not, please send a message to my WhatsApp. As I remember, in the previous day, I have discussed this question. If you are not in the class, or if I have not discussed it mistakenly, please send me a message. That is 2017 question, 2017 L question. That is the end of. So let's go back. This is 2016. 2015 is a very simple question. I think you don't want my help for the question. 15 is a so simple question, just very simple. But if it is difficult, send me a message. Send me a message to my WhatsApp so I can consider it. 14. This is the question given from our next lesson. So this is the third part of mechanics. What is the third section of mechanics, dear Lamai? Mechanics has three sections: linear motion, circular motion. So what is the third section, dear?
Fluids.
Fluid section. So this is given from fluids. Under the fluid, you will learn Bernoulli's equation. So this question is based on Bernoulli, as well as some other mechanics sections. Right. So that's what we are going to start next. That is our next section. Right. This is also a good question, which is given from circular motion. 2012. Let's start there. Read. This is 2012 first essay question. Right. Please write the heading 2012 first essay question. Let's read. In this question, you will investigate a few basic movements of a robotic arm as shown in the figure 1. In this question, you will investigate a few basic movements of a robotic arm as shown in figure 1. The arm segments A and B of the robot have the ability to rotate in either direction around the joints 1 and 2 horizontal planes. The arm segments A and B of the robot have the ability to rotate in either direction around the joints 1 and 2 in the horizontal planes. Okay. So it means A section can be rotated about 1 and B section can be rotated about 2. So 1 is a point, 2 is a point. Around the point 1, A section can be rotated. Around the point 2, B section can be rotated. What about C there? The joint 3, this one. The joint 3 allows segment C to move up and down. So segment C can be moved just up and down. Move up, move down. A, B are rotatable. C is only moving upward and downward. That's the simplest thing. Right. Right. Let's go. Assume that only one movement around O across a joint is allowed at a given time. Only one movement is allowed. So A and B will be at rest when C is moving. That's the move. That's the meaning. C and A will be at rest when B is moving. B and C will be at rest when A is moving. That's the meaning of this word, right? Allowed. Assume that only one movement around O across a joint is allowed at a given time. One movement is at a time. And that is no friction in any of the joints. No friction is there with any of the joints. Right. Simple A question. First, consider upward motion of the segment C. This motion is described by the velocity time graph shown in figure 2. Now you need the knowledge of velocity time graphs. If you have not studied graphs section, velocity time graph, displacement time graph, acceleration time graph, force time graphs, you must send me a message to my WhatsApp after the class. Then I can arrange some other classes for you to cover those sections. First, consider an upward motion of segment C. This motion is described by the velocity time graph figure 2. The mass of the segment C is 0.1 kilogram. Where it was C? This one, C. So this can be just moved up and down, move up, move down. So its motion is described by this graph. See, initially during the first 2 seconds, what kind of motion is there during the first 2 seconds? Lamai, what is this motion?
Uniform
Acceleration.
acceleration.
Constant acceleration. Very good. What is the motion described in the third second here? From 2 to 3 seconds? Only 1 second. What is that motion here?
Constant velocity.
Velocity.
Constant velocity. Final 2 seconds, 3, 4, 5, final 2 seconds.
Deceleration.
Constant deceleration.
Deceleration.
Constant deceleration. Clear? Now please write the heading as 2012 first essay question. Right? Write the heading 2012 first essay question. And write simple A and draw this graph. That's the first thing. Write the heading as 2012 AL first essay question. First essay question. Right? And write simple A and draw this graph. Essential. You have to do them. Start there. Right. It's better if you mark this angle as, look at board. Please mark this angle as alpha. This is angle alpha. Right. And mark this angle as beta. This is beta. And mark this distance as 2 seconds. You see, this is just 2. See, and what about this height there? What is this height, Lamai?
0.1.
0.1. Very good. And what is this length? Only 1 second. Am I right? Yes. Only 1 second. Yes. This is just only 1 second. Finally, what is this length here? It is again 2. Am I
2
right?
seconds.
Yeah, that is again 2 seconds. Right. Mark them all here. We need. This is only 1 second. This is 2 seconds. this height is 0.1. Right? So these things essential for you to understand the question. Right. Now my question is, right? Listen dear, please name these points also. Name this point as, let me use a different color. Name this point as X, Y, Z. Similarly, name these points as P, Q, R. So actually, I'm discussing a question. I'm teaching you. So I'm teaching you. So I am giving you all the possible details. That's it. So I have asked you to name the first triangle as X, Y, Z. This is Y, and finally Z. The next triangle should be named as P, Q, R. Check and mark them properly. P, Q, R. P, Q, R. That's it. Now we can answer the questions easily. Calculate the acceleration of the segment C during the first 2 seconds. So what is acceleration there? Acceleration equals, Lamai? Hello?
Average velocity divided by time.
No, yeah, it is true. It is true, but here it's a graph. So how do you find acceleration from a graph, dear?
Tan alpha.
Tan alpha, yes. The acceleration is calculated from a graph by the equation tan alpha. Please write there. This is the answer for Roman number 1. Acceleration is tan alpha. Right. What is tan, dear? You want to find tan alpha from XYZ triangle. So what is tan of a triangle?
Opposite of adjacent.
Opposite side divided by adjacent side. So opposite side is YZ, adjacent side is XY. So what is YZ there? Lamai? What is the length of YZ side?
0.1.
0.1. What is the length of XY side?
2.
2.
2.
Therefore, what is the acceleration? 0 divided by 2 is 0. 1 divided by 2 is 0. Then 10 divided by, because you have a decimal point. So 10 divided by 2 is 5. So this is the acceleration during the first 2 seconds. Complete there. Draw the graph and complete this answer. Okay. Right. Then let's go to the second question. The forces acting on C. See there. How many forces are acting on C there? The forces acting on C are its weight and the force applied by the motor. So it means there is a motor for the segment C to be moved. Right. So only two forces: weight of the segment C and the force given by the motor. Calculate the force applied by the motor during the first 2 seconds here. So during the first 2 seconds, I think this is more, yeah, consider motion, upward motion of the segment C. See, upward motion of the segment C. See this sentence here, upward motion of the segment C. Right. So how many forces are acting on the segment C here? If I draw the segment C separately here, right? So this is the segment C. They have given the forces acting on it. What are the forces acting on it, dear? Lamai? How many forces acting on the segment C, dear?
2.
2. What are the two forces?
Weight
Weight.
and the force
And
applied by
force
the
applied
motor.
on motor.
Very good. Weight means gravitation, attraction, force. Gravitation, attraction, force is always acting vertically downward. But here it is said that segment C is moving up. For the segment C to be moved up, the force provided by the motor should be acting upward. Am I right there? So this is the gravitation attraction force mg Newton. The segment C is moving up. What is the acceleration of the segment C during the first 2 seconds there? Let me mark it as A1. We have found it as 0.05 meters per square seconds. That's what we have found, right? So for the motor to be moved up, for the segment C to be moved up, there must be an upward force. So let me take that force as Fm. Fm means force given by the motor. Would you please draw this figure here? Then the story will be much clearer for you. So Fm is the force given by the motor, right? Draw this figure here, please. So I'm going to answer. I'm going to give you the answer for Roman number 2. A Roman number 2. For A Roman number 2, I have drawn this figure. This is the segment C. This is the segment C here. This is C. Right. So what should I do to find the force given by the motor here? We know the mass of segment C is 0.1 kilogram. So what should I do to find the force given by the motor C?
Apply figures in me.
Yeah. Can you give a try here? Apply F equals ma, find the force given by the motor, that is Fm, and send your answer to my Zoom chat. Start there. Right. So let's just apply F equals MA. By applying F equals MA to this segment C, you can find the acceleration. Right. So we must indicate the direction. Do not forget to indicate the direction vertically upward. Vertically upward. Let me apply the equation F equals MA. There are two forces. The upward force is Fm, downward force is mg. Therefore, the total upward force is Fm minus mg. Mass is mass of the object 0.1 kilogram. Acceleration is 0.05. Right. So Fm minus mass of the object 0.1. Simple G is 10. What is this there? If you multiply this, what will you obtain? 0.1 into 0.05. Another decimal place will be added because of this 0.1. That's the only thing happens. One more decimal point will be added and final answer will be 0.0, another 0 and 5. That's it. So then Fm equal Fm minus 0.1 into 10. 0.1 into 10 is 1. Equals 0.005. Just take 1 to the other side, then you can subject Fm. So Fm equals 0.005 minus 1 comes to this side as plus 1. Am I right there? Minus 1 comes to the other side as plus 1. So finally, you will get the answer as 1.005 unit is Newton. So this is the force given by the motor. Who got this answer? Lamai? Lamai, who got this answer? Please raise your hand up if you have obtained this answer. Right. Very good. Excellent. Superb. Right. I think time is enough. Let's go. Let's check the next question that they have asked. Right. I think time is enough. So let me check the next question that they have asked. Right. Let me move this up. Roman number 1 we completed. Roman number 2 we have answered. Now we should check for Roman number 3. Right. Read what they have asked in Roman number 3. What are the magnitudes? What are the magnitudes and direction of the force applied by the motor on C during the last 2 seconds? So what will happen to the motion during the last 2 seconds here? What kind of a motion is there during the last 2 seconds? Lamai?
Constant deceleration.
It's a deceleration. Constant deceleration. Very good. So did you write this? I won't erase this because I do not have enough space. Right. Please write them. If not, take a screenshot. I want to erase. So during the last 2 seconds, it has a deceleration. Right. So please write for Roman number 3. Please write Right. Let me take the graph. Right. This is the graph. Right. Please try it. During the last 2 seconds, the segment C is moving with a deceleration. Roman number 3 and right. During the last 2 seconds, the segment C is moving with a deceleration. During the last 2 seconds, the segment C is moving with a deceleration. Okay, dear? Right. How do you find the deceleration, Lamai? What is the equation? What is the equation of deceleration? From a velocity time graph, how do you find the deceleration, Lamai? Whether it is acceleration or deceleration, always tan alpha, tan beta gradient. So deceleration is also deceleration. You have to find it from the PQR triangle. So deceleration equals tan beta. Write it here, quick. Deceleration equals tan beta. I have written beta in very big size. So how do you find tan from this PQR triangle, Laman? Somebody please tell me. Which side divide by which side? Lamai?
RQ divided by QP.
RQ divide by, yes?
QP.
QP, very good. RQ divided by QP. Adjacent side, sorry, opposite side, RQ, OQR, divided by adjacent side, opposite divide by adjacent. So RQ divided by QP. OPQ, anything, right? So RQ is, Lamai, what is the length of RQ, dear? This side?
0.1.
0.1. Very good. What is QP distance, dear?
2 seconds.
2 seconds. Therefore, 0.1 divided by 2 means we get the same value, 0.05. Am I right, dear? Do not forget the units. So this is the deceleration. So when something is moving with the deceleration means, if we use say acceleration, we should use Lamai. Deceleration is this. So, but if you say it is an acceleration, what should you use, dear?
Minus sign.
Very good. We must use a minus sign when we use it as a acceleration. Very good. So it means if you use the equation v equal u plus at, or if v equals ma, or any other equations, whenever we use it as an acceleration, we should use a minus sign. That's the meaning. Right. Complete it there. what should I do to find the force given by the motor during the last 2 seconds here? Lamai, what should I do to find the force given by the motor during the last 2 seconds?
Apply F equals MA.
Very good. To which direction here? We should apply F equals MA, but to which direction? Segment C is still moving up. Am I right? Can you hear me clearly?
Yes, sir.
Right.
Yes, sir.
Segment C is moving up. If it is moving up, all the equation should be applied vertically upward. So indicate the direction by a black color arrow and write we apply F equals MA upward. Now listen to me, dear. Still there are 2 forces. Now the new force given by the motor, let me use it as Fm2 or F2. F2 is the force given by the motor. So we don't know its direction here. I'm applying the equation upward. F equals MA is applied upward. Right? So force given by the motor should be upward. That's how I think, because the segment C is moving up. Minus gravitational attraction force always acting downward equals M. What do you think about the acceleration now? Is it an acceleration or a deceleration?
Deceleration.
Deceleration. Therefore, the segment C is moving up with a deceleration of 0.05. But in F equals MA equation, A means acceleration. So if we use the value of deceleration, in the place of an acceleration, we should use a minus sign and we should write 0.05. Why there is a minus sign there? Why there is this minus sign?
Because
Deceleration is considered
Because
as
it's a deceleration. This capital M is 0.1 kilogram. I think you can do the rest and find the value of F2. F2 is the new force given by the motor to the segment C. Start there, find the value of F2 and send your answer to my Zoom chat. Start. Right. So let's see this. F2 we don't know. Minus M is 0.1, G is 10. Equals, now there's a minus sign. See, there is a minus sign. So let me write the minus sign first. 0.1 into 0.05. So when you multiply this 0.1, decimal points is increased by 1. So this will be 0 point, another decimal point will be added than 5. That's what will happen. Who would like if I explain this simplification? Please raise your hand up. Who wants to know how I get this 0.1 multiplied by 0.05 as 0.005? Anybody in the class? Nobody wants. Okay. So this is F2 minus 0.1 into 10 is 1 equals minus 0.005. So let me take this minus 1 to the other side. Let me take this minus 1 to the other side. Minus 1 goes to the other side as plus 1. So F2 equals minus 1 comes this side as plus 1 minus we have 0.005. So if you subtract this, this is much very simple, right? It's so simple. So then you get, if you subtract, you will get this is 0. You have to take this 1 to 1 decimal point. So this will be 10, this will be 10, and this will be 9, this will be 9, and this will be 10. 10 minus 5 is 5. So it means 0.995 Newton. Am I right there? Mama, is this clear? So it means still the force given by the motor is acting upward. That's the meaning. Still the force given by the motor is acting upward. Lamai, please complete this. So we have found the force given by the motor as 0.995 Newton during the last 2 seconds by applying F equals MA vertically upward. Who got this answer? Raise your hand up if you have obtained this answer. Very good. Excellent. If you have any doubt or any difficult point, send a message to the Zoom chat. Right. Shall we go to the next question here? Who wants more time? Somebody please raise your hand up if you want any more time to write the things. Right. So let's go for the next question. Let's give a try. We have answered Roman number 1. We have answered Roman number 2. Roman number 3. What are the magnitude and direction of force applied by the motor on C during the last 2 seconds? The direction is upward. If they ask you to write the direction, please write direction of F2 is upward. Direction of F2 is upward. Please write it here because they ask a direction. Direction of F2 is upward. Now let's try for Roman number 4. Suppose the magnitude of the force, I'm talking about Roman number 4. Suppose the magnitude suppose the magnitude of the maximum force that the motor can deliver is 12 Newton. Is it 12 Newton or 1.2 Newton? Let me check the question paper one more time because there was many typing mistakes. Suppose the magnitude of the maximum force that the motor can exert on C is 1.2 Newton. I'm so sorry. Please correct this as, please correct the mistake as 1.2 Newton. Maximum force that the motor is able to give is 1.2 Newton. This is 1.2 Newton. Unfortunately, it is printed as 12 Newton. Suppose the magnitude of the maximum force that the motor can deliver is 1.2 Newton. If the start from rest, C moves up under this maximum force for 0.5 seconds, how far will it move? Can you understand it? Suppose the magnitude of the maximum force the motor can exert on C is 1.2 Newton. If starting from rest, C moves up under this maximum force for 0.5 seconds, how far will it be moved? So first of all, what should you do, dear? We know the force, we know the mass. They ask us to find the distance traveled by the motor. So what should the distance traveled by the segment C? So what should we do, dear? Lamai?
Find acceleration.
Find the acceleration. Very good. That's it. So for Roman number 4, for the Roman number 4, vertically upward, let's apply F equals ma. That's what we want to do. The upward force is the force given by the motor, Fm. The downward force is mg. Equal mass is 0.1, and we don't know what the acceleration is, 0.1 into a. Can you do the rest and find acceleration, dear? The first thing that you want to do is find in the acceleration under this maximum force. Right? Right. So the new Fm is 1.2, capital M is 0.1, G is 10. This is 0.1 into A. Can you do the rest and find the value of simple A? Simple A is the upward acceleration of the segment C under the maximum force of 1.2 Newton. Find the answer and send your answers to my Zoom chat. Start. Interesting. Many answers are given. This is 1.2. 0.1 into 10 is 1 equals 0.1 into A. 0.1 into 10 is 1. So what is 1.2 minus 1.2 minus 1 there? 1.2 minus 1 is, yes, dear?
0.2.
0.2 equals 0.1 into A. Now, very simple. I can write 0.2 as, look at board, I can write 0.2 as 2 divided by 10. Right? So there are simplification method. 0.1 can be written as 1 over 10. Am I right, dear? Right? Into A. What did I do? I have written 0.2 as 2 divided by 10. I have written 0.1 as 1 divided by 10. So then what will happen? This 10 and 10, this 10 and this 10 cancelled out. Finally, you will obtain that A equals 2. Only 2 will be there. 2 meter per square seconds. Who got this answer, Lamai? Right. So they ask maximum velocity. If this force is applied for a period of 0.5 seconds, what is the maximum velocity obtained by this segment C? What should I do to find the velocity here? There's an acceleration of 2 meters per square seconds. The force is applied for a period of 0.5 seconds. So it means the object moves with this acceleration of 2 for a period of 0.5 seconds. So what should I do to find the velocity? Lamai, what should I do to find the velocity? You are tired, right? So it's so simple. Just yes.
Plus U plus 80.
Very good. Yes. To the upward direction, apply V equals U plus 80. So it starts from rest. So it means initial velocity 0. Acceleration, we found it as 2. Time taken, they have given it as 0.5. So what is 2 into 0.5 here? This is 0 plus 2 into 0.5 means 1.0. 0 plus 1.0 means 1. Am I right here? What is the maximum possible velocity? Lamai? 1 meter per second. Am I right here?
Yes, sir.
So what is the displacement here? I think they have asked in the next question, they have asked the displacement also. If they ask you to find displacement, what should you do? We found the velocity. The segment C is moved under this maximum force of 1.2 Newton for a period of 0.5 seconds. We want to find the velocity also. So we want to find the displacement also. How do you find it?
SC equals UT plus half AD square.
SC equal UT plus half AD square. Yes, very good. So let us apply along the upward direction. Along the upward direction, let us apply S equals UT plus half AT square. Can you do the rest? Can you do the rest and find the displacement? Send your answers to my Zoom chat. Start, Lamai. Send your answers to my Zoom chat there. If you have found S, send me the value of S. Let's see. Initial velocity is 0. So it means U is 0. Time is 0.5 plus half into acceleration is 1. Time is 0.5 and you have to get the square. Time is 0.5 but t square 0.5. This is t square. What will happen there? 0 into anything is 0 plus half. Let me write half as half.
So acceleration is 2, right?
Accelerate. Yes. I'm so sorry. Acceleration is 2. Yes. Why not? Acceleration is 2. This is 2. Right. Then what will happen? Yes, actually, yes, acceleration is 2. Then what will happen here? Into what is 0.5 square here? 0.5 square is 0.25. Now this 2 and this 2 cancelled out. So the displacement will be, Lamai? What will be the displacement there?
0.25.
0.25.
Very good. That is 0.25 meter. Do not forget the unit. In meters, it is 0.25. If it is in centimeters, it will be 25. Who got this answer here? Who got this velocity and displacement answers correctly? Velocity 1 meter per second, displacement is 0.25. 0.25 meter means 25 centimeters. Very good. Many of you have obtained the correct answer. I'm so happy. Complete it there.